Picture this. You're standing inside Wembley Stadium and a single drop of water falls on the ground. You barely notice it, but then every minute that drop doubles in size. 2 drops, 4, 8, 16. How long before the stadium, all 4 million cubic meters of it, is full to the brim of water? The answer? 46 minutes. You'd barely make it to half-time. Even if we're familiar with the idea of exponential growth, it can still feel just wrong. We see something that's very small, then quite small, then still pretty small, then suddenly it's massive. But this isn't just about hypothetical stadiums filling with water. In the real world, exponential growth is everywhere. If our bank savings earn interest, we then earn interest on this interest, and interest on the interest on the interest. Pandemics like COVID or outbreaks of measles in under-vaccinated populations seem to explode suddenly because each round of transmission builds on all the transmission that occurred before. And yet, it's easy to misunderstand exponential problems. People underestimate how much effort they'll need to stop an epidemic, or they underestimate the value of early action in growing a community or an investment. The more time that passes, the more opportunities for growth upon growth upon growth. Why is exponential growth so counterintuitive? It's because life is generally linear. Run the tap for 2 minutes, you get twice the water. 3 minutes, triple. The amount you pay for food or fuel scales with the amount you consume. The cost doesn't suddenly accelerate the more you spend. As children, we're taught to write numbers on an evenly spaced line. But here's the thing, we're not necessarily born thinking that way. Studies have found that young children, and even some indigenous communities, think of numbers relatively. To them, the distance from 1 to 2 is the same as the distance from 4 to 8. This is helpful for visualizing exponential processes because getting from 1 to 4 takes the same time as getting from 4 to 16. But over time, we're taught to be linear. So when exponentials hit us in real life, we can really struggle. How can we get better at understanding exponential growth? First, try it yourself. Calculate what happens if something doubles every minute. See the remarkable acceleration. Second, think in terms of doublings. If something is just increased from 500 to 1,000, don't assume a number as high as, say, 8,000 is miles away. Say it's just doubled. With 3 more doublings, we'll be at 8,000. Third, learn useful shortcuts. I like the rule of 72. If something's growing at X% per week, it'll take about 72 divided by X weeks to double. If something's growing at 6% per week, for example, it will double in about 12 weeks. Fourth, make predictions, then revisit them. Write down what you think will happen with an exponential process. You'll start to see just how skewed your intuition can be when it comes to some of the biggest threats we face. You might underestimate the problem entirely, as well as the action we need to take to deal with it. But finally, we shouldn't just fear exponentials. We should make use of them too. Compounding investments, viral knowledge and insights, growing social movements. Exponentials can be really powerful, but only if we think exponentially.